Do I ask you all the different things about the graph of this? Okay. So when you're looking at this function and you're going to be asked questions about its graph, you first need to determine you're dealing with a log, so it's going to be the inverse of either growth or decay. Can we tell which one is going to be? It's the inverse of. The base is greater than 1, so it's going to be the inverse of growth. So our parent function is going to look like this, right? So that's the parent function that we're looking at. And again, that basic form has a vertical asymptote at x equals 0. And let's go see what we know about this graph. Well, on the outside right here, we see there's a vertical shift that occurs. The vertical shift goes up 2. And we see on the inside there is a horizontal shift. The horizontal shift moves what direction? To the right or to the left? What value of x gives you a 0 inside here? Positive 4. Positive is to the right, so it moves to the right 4. Well, the horizontal shift also allows us to find our vertical asymptote, right? So the vertical asymptote is going to be x equals whatever that horizontal shift is, 4. So 1, 2, 3, 4. So here is our vertical shift. I'm sorry, the horizontal shift gives us our vertical asymptote at x equals 4. And then the last, so we know that the last step that we can use for this, again, let me go back up. There is no horizontal asymptote that would have been affected by, possibly affected by a vertical shift if it was an exponential function. And so the last thing that we need in order to identify this is the x-intercept. Now, I may not have asked you for that in this, but you can probably expect to see it on quizzes. And so if you needed to find the x-intercept, what you're going to do is you're going to take your function, set it equal to 0, and solve. So log base 6 of x minus 4 plus 2 is equal to 0. And in order to solve for that, we isolate the expression that contains our x. So we're going to subtract 2 from both sides. So negative 2 is equal to log base 6 of x minus 4. And now once we get that expression with the x is inside the log, once we get that expression isolated, we can rewrite the form. So we're going to rewrite this in exponential form. So we take our base of 6 to the power of negative 2 and set that equal to the expression inside our log, x minus 4. Okay, so 6 to the negative 2 is 1 over 6 squared, or 1 over 36. And so if you needed to solve for x here, we're going to add 4 to both sides. And if you looked at this, adding 4 in terms of 36s, if you multiply 36 times 4, you get 30 times 4 is 120. 6 times 4 is 24. 120 plus 24 is 144. You wind up with, if you add those together, 145 over 36 is what x is. So again, this is not an easy, simple number necessarily to express, but 145 over 36, comma 0. There's our x-intercept. Well, really, we know that this is 4 plus 136. So it's going to be right here, just past 4. So we can sketch our graph. It's going to look like this. So this is the blue is the graph of our solution. And so based on that graph, we can answer the other pieces of information about the left and right behavior. To the left, it approaches down to the asymptote. To the right, it continues to rise or go up. And if you needed to identify the domain and range for this, the domain for these log functions are always going to be from the vertical asymptote to infinity, with the ones, unless there's a reflection across this asymptote, but I don't think you're going to see any of those. Okay, so it goes from 4 to infinity. It doesn't include either one. And then the range for these log functions are always going to be all real numbers. So we go from negative infinity to positive infinity for the range.